Hello, I am Ashley Maxcey, and I am excited to share with you two case studies of very long-term retention. My co-authors on this project are Rich Schifrin from Indiana University, Denis Cousineau from the University of Ottawa, and Richard Atkinson from the University of California in San Diego. In the first half of the talk, I will be presenting a case study demonstrating very long-term retention of word lists by Richard Atkinson. In the second half of the talk, Denis will be presenting a second case study demonstrating memory for perceptual stimuli after 22 years. The studies presented today are published in an open access article in Psychonomic Bulletin and Review, and we hope you will read and of course cite our paper. We also want to thank Elizabeth Loftus, Jeff Zaks, and Colin McLeod for extremely useful feedback on that paper. The inspiration for this project came from the same place the inspiration for everything we do comes from, Atkinson and Schifrin. Just kidding, but it really did come from Atkinson and Schifrin. Here's a quick clip of Rich Schifrin describing the motivation for this project.
This project began when Dick Atkinson asked for his thesis at IU in the 1950s. This was an important thesis because it actually used many of the techniques we are still using these days to do modeling of cognition and modeling of memory. When he asked for this thesis, he remembered not the words or the procedures, but the fact that he thought he would never forget the words that he had used at the thesis at the time, even though now he had no recollection at all. And that led to our subsequent decision to actually test his memory.
Here you see an image of Richard Atkinson's dissertation titled An Analysis of Rote Stereoposition Effects in Terms of a Statistical Model, submitted to the Department of Psychology at Indiana University in 1954. In his dissertation research, Atkinson presented the subjects with lists of words. These lists were used in an anticipatory learning task, which means that subjects had to learn the order of the lists such that when they were presented with one word, they would verbally report the upcoming word or anticipate the next word on the list. For example, at the top of list A, you see the word glossy is followed by overt. This means that when the subject was presented with glossy, a correct response would be to say overt. At the time of his research, published in 1954, Atkinson had to have perfect mastery of this list to score the participants' verbal responses. In early 2021, 67 years later, we presented Atkinson with a similar anticipatory learning task in which the word lists, unbeknownst to him, were all from the dissertation, but half were presented in the original order and half were presented in a scrambled order. The original and scrambled halves were counterbalanced, such that in one session, the original lists were first, and in another session, the scrambled words were first on the list. If he had any memory for those original lists, then Atkinson would relearn the words listed in their original order faster than he would relearn the words listed in a new scrambled order. Atkinson was unaware of the experimental manipulation. He reported no awareness that any of the words were from his dissertation, but he incorrectly presumed that the experimental manipulation involved some of the old words from the dissertation and some new words. Atkinson and I conducted these experimental sessions over Zoom, and all sessions are recorded. Here is a short example of a few words.
Precise. Timid. Uphill.
Here you can see the results of this case study. On the y-axis are the trials, which are runs through each list. Each list was cycled through 15 times. On the y-axis, you see the number of correct responses from a list. So to orient you to this figure, I want you to note that on trial 1, there were no correct responses, which makes sense because this trial is the first time he is relearning those lists. The red line shows the number of correct responses from the half of the list presented in the original order, and the green line represents the number of correct responses from the half of the list presented in the scrambled order. You can clearly see what pattern emerged. The take-home point here is that relearning of the original order was superior to relearning of the scrambled order, with performance nearly twice as good for the original order. While we acknowledge that scientists rarely like anecdotal data such as this, we nevertheless find these results impressive and worth reporting, both because of the impressive memory across an extremely long interval, and also because the subject is a well-known memory researcher himself. Now I'm going to turn it over to Denis, who will discuss case study number 2.
Thank you very much, Ashley. So I will be presenting the second case study. My name is Denis Cousineau, and it turns out that I am the second participant presented in that study. So case study number 2 was slightly different from case study number 1. Number 1 was with letters and words. The case study 2 is for a skill. So the participant was invited to do a visual search task in 1998. So 20 years ago. It's far less impressive than the first case study. However, the advantage of this second case study is that we have a lot more data. So the participant was trained initially in 1998 for completing 59 one-hour sessions of a visual search task. And then he accepted to be retrained in 2020 for an additional 15 one-hour sessions. In both cases, the exact same procedure was used so that the results are completely comparable. The search task in 1998 was a difficult search task. It was to search for objects that were abstracts. So you can see on the top left, there was 4 targets which were defined by various lines around a circle, and the distractors, the foils, were similarly built with lines around a circle. So the task was, as usual, a fixation star, a novel manipulation. There was an indication of where the objects will be appearing, and then the object will be appearing, and the participant has to say, yes, there is a target, as it is the case presently, or no, there is no target on that trial. On 50% of the trials, of course, there was no target. We also, it's not shown on this slide, but we also manipulated the asynchrony of the presentation of the various features. It was exactly identical in 2020, sorry, but it's not relevant for the present talk. Also, the participant accepted to do a control task where he learned for a new 15 sessions novel objects. So these objects look completely different, but they were built exactly following the same rules. So if you look for the target, it has a feature 1, and this target here has a feature 1 as well. So the features in that case were small squares. And the trials went exactly identical as with the previous objects. If we look at the results in 1998, these are my own results. We can see that I have a learning curve. So I started fairly slow, making responses on average in more than 1 second. And as training goes on, my RTs, my response times, improved until I reach a plateau more or less after 40 sessions in being able to detect a target in roughly 500 milliseconds. So the blue line is the target present responses, and the green line is the target absent responses, average across all the conditions. If we look at the new 2020 results, then we have this curve. I will come back to the RTs in a minute. Just to show you also with the new objects, I have this kind of curve. So if I broke down the new retraining data, we can see that I started in 2020 more or less with the same performance that I had after 20 sessions in 1998. So I didn't start from 0. There was a huge gain over there. We could say that the amplitude of the curve was divided by 4. Also in 2020, I reached an asymptotic performance more or less after 8 sessions, whereas it took approximately 40 sessions in 1998 to reach that plateau. So again, not only I started much better, but I reached the plateau, the asymptote much faster. If we look at the new stimulus set, the squares within the rectangle, well, there's not at all any hint of advantage. If I look at the early session, I'm more or less identical to the early sessions back then in 1998. And if I look after 15 sessions, I have more or less the same results that I had in 1998 after 15 sessions. Actually, the two sets of curves can be more or less put one on top of the other, and we can't see any difference. So for the new object sets, the new set of objects, absolutely no gain. But for the old ones, a huge gain in response times. So if I was to conclude on the case study 2, we can say that there's an almost perfect retention right from the start and a very fast relearning so that I reach asymptote in just a couple of sessions, whereas it took 40 sessions back in 1998. This is a neat example because in that with that set of objects, there's very little chance that I lived interferences. I don't go by streets and see this kind of object around me. So I just did the experiment in 1998, and then more or less I never saw those stimuli again, except occasionally when I was preparing a manuscript or rereading some of my old manuscripts. That's it for case study 2. If you're interested in seeing the slope or the variances, we also have those data. Actually, we have all the data. That's the neat point about this case study. To sum up, so we have seen 2 case studies, and I can make a few take-home messages. One is for you. As a researchers, you may probably think that you will never forget your PhD thesis. Well, it turns out you're right. Atkinson's results show that we still have very, very good memory for what we did in our thesis 67 years later. So you may never forget your PhD thesis, like it or not. More generally, the result shows that the long-term memory should better be called a very, very long-term memory system. I mean, 67 years, it's a lifespan, and very little forgetting about across that lifetime means excellent memory system. We have to point out a few limitations. Of course, the case studied in that presentation are not representative of the general population. Both of us are highly educated people. We kept educated. We read a lot. So I don't think we are very representative. But in a sense, that's a good thing because the results from the first case studies, we may expect a lot of interferences. Certainly, Richard Atkinson saw those words hundreds or thousands of times across his life in different pairing. So he experienced interference maybe daily, and yet he showed excellent retraining. And for the second case, well, I never saw those objects again, so I'm an excellent illustration of what decay can do. And apparently decay doesn't influence much my learned skills. So these are the take-home messages. Thank you very much. If you have questions, Ashley and I will be very happy to answer them. Thank you.